Hello class, welcome to Unit 4, Lesson 4. Today we're going to continue solving exponential and logarithmic equations. The only difference is today we're going to go ahead and use these techniques to solve application problems that involve compound and continuous interest. So we should remember our equations from earlier in this chapter, but we had our compound interest, was A of t equals our principal P, and then we had 1 plus R over N. R was our rate as a decimal, and N was our number of times compounded in a year to the NT. And then we had compounded continuously was our PERT. A of t equals PE to the RT. So today we're going to be giving word problems, and then we're going to be solving for different values, okay, using the techniques that we used earlier in Unit 1, Lesson 4. Okay. So the first problem is we have a girl, she invests $4,000 into an account that pays 7% interest per year, compounded quarterly. So she starts out with $4,000, that's our P, and then R is our 7%, which we make sure we write as a decimal, so 0.07. And then it's compounded quarterly. Quarterly is 4 times a year. Okay, so it's the information we have. So it says find the amount in the account after 4 years. So let's just write the equation out. We would have A of t is equal to our principal, 4,000. Then it is 1 plus our rate, 0.07, over our number of times compounded, 4, to the 4t, nt. Okay. That would be for any time. This problem is specifically asking us to find it after 4 years. So we are plugging in 4 for t. So we're finding A of 4, which is 4,000. 1 plus 0.07 divided by 4 to the 4 times 4. So I would recommend you take a second, type it into your calculator, and we find the answer. So 4,000, 1 plus 0.07 divided by 4. To the, and you could write 4 times 4, or if you wanted to, you could just type in 16. Then you'll get your answer. We are talking about money, so you must be certain that you round to 2 decimal places. So 5,279 point, it says 717, so it's going to be 72 cents. Okay, that is our value after 4 years, or her value after 4 years. So this is the type of problem we did earlier in Unit 4. Now we're going to go ahead and we are going to solve for time. Okay, we're going to be solving for t. So it's asking us to find the time it would take for the money to double. Okay, well currently she has $4,000, so if her money doubles, she now has $8,000. So I'm going to take the 8,000 and plug it in for this side, the A of t side. Okay, so that's when I want to know what I will get out. So I will have 8,000 is equal to 4,000. Then we'll have 1 plus 0.07 over 4 to the 4t. Then we've got to use our techniques. The part that is raised to the exponent, we have to isolate that. So in order to isolate it, we're going to go ahead and divide by 4,000. And in this process, I am also going to, I'm going to write this down. I'm going to type this into my calculator because that kind of gets a little much to write every time. So what is 1 plus 0.07 divided by 4? That gives us, and don't round at all, but this is really the number 1.0175 to the 4t. You could keep typing this the whole time, or writing this the whole time, it just kind of gets to be a lot. And now, what do we do that we have this by itself? We have to get the variable out of the exponent, so we log on both sides. So we have log of 2 equals, this allows us to take our exponent and put it in front of our log, so 4t log of 1.0175. And now we just need to get we need to get t by itself. So it's 4 times t times log of 1.0175, so I would divide by 4 log 1.0175 on both sides. This will cancel. So t equals log of 2 divided by 4 log of 1.0175. Now, it seems silly, but I promise you people get things wrong just because they make mistakes typing into their calculator. I need this all to be in parentheses, so divide, okay? And then this will have parentheses, so if you type it in. Now, this is talking about time. So for time, if the directions don't specify at least 3 decimals, I'm going to round this one to 4. If you type it in, you should get 9.9885, and then the label for the year, for the time is, yes, years. So just under 10 years. After 10 years, she will have doubled her money. So it's a pretty good deal for her. Okay. Example 2. We have a sum of $8,000 was invested for 4 years and compounded quarterly. If this sum amounted to be $10,200, what was the interest rate? Ooh, so this one's a little different. We're going to solve for R in this case. Okay, so let's figure out what we know. We know it's a compounded quarterly, so I will be using this equation. And basically, if I'm solving for R, I need to be able to fill in everything else. Okay, so a sum of $8,000 was invested. That's what the starting amount, so that's your P. Okay, so this is 8,000. For 4 years, that means T is 4. Compounded quarterly, that means N is 4 times a year. And its sum amounted to be, so this is what it ended up being, was $10,200. I got carried away with my zeros there. 200. Okay, so if I set it up, I have 10,200 equals 8,000, 1 plus R over 4 to the 4 times 4. Okay, so our goal is to get R by itself. Well, it's inside here, so still I need to isolate this part, so I'm going to get rid of my 8,000. So I divide both sides by 8,000. And I'm just going to see, I know my zeros will cancel here. What's 102 divided by 80? Doesn't work out too bad of a decimal, so I'm going to write it as a decimal. 1.275. You could also keep it as a fraction, a reduced fraction if you wanted to. But I got 1.275 equals 1 plus R over 4 to the 16th. Now, my exponent is not a variable. It is a number. So in order to get rid of numbers, you would, for instance, this is a little side note, but if you guys had x to the second equals 4, whoops, you take the square root. So in this case, we don't need to take the square root, we need to take the 16th root. I do not have access to my calculator here today on my screen, but what you would do is, I'm going to write it out. We're going to do 16th root. These will cancel. So I have to have the 16th root of 1.275. So 16th root of 1.275 equals 1 plus R over 4. Okay. I'm going to wait until I have R all the way by itself because I want the most accurate answer. Okay. So from here, to get R by itself, I would subtract 1. Equals R over 4. And then we have to go ahead and times both sides by 4. All of it. Okay, so R will equal, and I want this out at least to 3 decimals. We do 4, parenthesis, and then to get the 16th root on your calculator, you go math. And below your cube root, there should be an x root. Okay, so if I go to that one, it's number 5. Ooh, actually, you might have typed 16, whatever the root is first. So we do 16, let's try this. 16, math, then we go to 5. Yep, then it'll put it in that little spot, and then you type in 1.275. Okay, you subtract 1 from it, and then take that answer times 4. You could have put it all in parentheses, and you should get that R is 0.06120. Lots of zeros. Okay, that's R, but we need to make sure you put it back as a percent. So it's really 6.120%. Okay. So there is our answer for example 2. So you got to be careful. That one was asking us for a rate. We actually did not need to log on it. Okay. Example 3. Find the annual interest yield for an investment if it earns 6.5% compounded quarterly, okay, per year compounded quarterly. So what I have is, I have my AFT equals my principal, then I have 1 plus my rate, I'm going to write it out, R over N to the NT, okay? So in order to solve this one, they're asking us to find the annual interest yield. Okay, well, annual means 1 year. So really we can assume T is equal to 1 when I solve this type of problem. Okay, and then I'm going to go ahead and put in my quarterly and compare it. Okay, so let's just start plugging in what we know. Our A of T will equal our principal. We do not know that, but we know it's 1 plus our rate, so 0.065 divided by N, which is the number of times we're compounded, so 4, to the NT. So N is 4, and our time is for 1 year, which is 1. Okay. Come on. So what you're going to do now is you are going to type this part in to your calculator. And we're going to get an answer. Okay. Type into calculator. And when you do that, you should get that it is 1.0666. Okay, that part right there is that. So now what we want to do is find the annual interest yield. So what we need to do is we need to compare it to something that is compounded annually. Okay, so then we're going to compare to compounded annually. So to be that, we would have A of T equals our principal, 1 plus, okay, the rate, which we don't know, because we're trying to figure that out, all over the number of times you are compounded. Well, in this case, if we're comparing it to the annual, it's compounded once a year. Okay, all to the 1 times 1. So we will have 1 plus R, really is what we have there. And now we're going to take this part and we compare them. This is the annual versus the quarterly. So if you were to compare it, 1.0666 equals 1 plus R, and you solve for R, R would be 0.0666. So what this tells me is if I was going to have an account, the annual interest yield, how much I get for the entire year, if it was only going to be compounded once, would be 6.66%. Which is actually a little better, right? Because if you're compounding quarterly, that means every quarter they take the amount of money you've made in interest and then it goes towards your principal. So then you compound on it again. So this is how much you would make annually, 6.66%. Okay. All right. Here is a your turn. I'm going to have you pause and go ahead and do this your turn problem on your own. Okay. So the first one is find the amount in the account after 20 years. So she has $5,000 and it pays 3% compounded monthly. So using that equation, we would start out with our principal. Then it's 1 plus our rate, so as a decimal, 0.03 over N. Monthly is 12. There's 12 months in a year. To the 12T. Now we need to figure out for 20 years. Okay, so we're going to go ahead. Oop, that does not separate. So we need to find A of 20. So we will type in all of this, and we're going to plug in a 20 here. So when you do that, after 20 years, you should have $9,103.77. Okay. So the next question asks, how many years would it take for Marcia to have $12,000 in her account? So we're going to take this equation up here and set it equal to 12,000. I'm actually going to see what this gives me. 1 plus 0.03 divided by 12. Okay, it's 1.0025 to the 12t. And now we just need to solve it. We need to isolate the part that is raised to the exponent. So we're going to divide both sides by 5,000. So we have 12 over 5, 2.4. So 2.4 equals 1.0025 to the 12t. Now in order to get that out of the exponent, you log on both sides, which allows us to take this exponent and bring it down in front. So I have log of 2.4 equals 12t log of 1.0025. And then to get t by itself, we would divide by 12 log 1.0024. Okay. That would get t by itself. So I'm going to type this part in to figure out what t is. So I have log of 2.4 divided by, and then make sure you put the entire bottom in parentheses, 12 log 1.0025. And when you do that, this is talking about t. We solve for t. This is years, so at least 3 decimals. We would have 29.21, I'm going to do 4 decimals, 188. And then this is in years. Okay, so it would take 29.2188 years. So let's think about, does it make sense? After 20 years, she would have $9,100. So should it be more than 20 years to get $1,200? Yes. Okay. So there is your answer for 1B. All right. The next one. Okay, let's go ahead and do this one. So the sum of $3,250 was invested for 6 years and compounded semi-annually. If this sum amounted to $4,200, what is the interest rate? So we're going to plug in everybody we know to this equation, and we're trying to find the interest rate, so we are going to try and find R. How much money did we have at the end? 4,200. And we started with 3,250. Then we have 1 plus our rate, which we don't know what that is. And semi-annually means twice a year. And then 2 the 2, and then do we know how many years? 2 times 6. Okay. So we need to go ahead, isolate this piece. So I would divide both sides by 3,250. So those zeros for sure cancel. So 420 divided by 325. Not very nice. We're going to leave it as a fraction. A reduced fraction, it's 84 over 65 equals 1 plus r divided by 2 to the 12th. Now in order to get rid of this 12th, we take the 12th root on both sides. Okay, so we have the 12th root of 84 over 65 is equal to 1 plus r over 2. I would then subtract 1 from both sides. 84 over 65 minus 1 equals r over 2, and then times both sides by 2 to get our rate. All right, so on your calculator, you do 12 parentheses. Then you're going to type 12. Sorry, we would type 2 parentheses. Then you're going to type 12. Then you're going to go math and go down to your x root, which is your 5 button. And then you do 84 divided by 65. Then to get out of your root, use your arrow over and then minus 1. End your parenthesis. And you should get that r is equal to 0.043198. I'm just writing it all out at this point, but there it is. Let's round to 4 decimals. 1, 2, 3, 4. So this tells me that this has to become 2. So it's 0.0432. And then let's write it as a percent. So R equals 4.32%. So that would be the interest rate for that one. Okay. And then the last one, we're going to do example 3 on your turn. is to find the annual interest yield for the investment that earns 3.5% compounded monthly. So basically we have to compare compounded monthly to annually, okay? So compounded monthly to annually. So if I'm compounded monthly, my R is 3.5%, which is 0.035. Okay, we're trying to find the R over here for annually, so we don't know that. Then I also know that my N for compounded monthly is 12, and my N for annually is 1. And let's see, what else do I know? My time. We're going to talk about annually, so we're just going to compare it to 1 year. It doesn't matter what our principal is. Okay, so for this one, we'll have A of t equals P. Then we have 1 plus our rate, 0.035, divided by 12 to the 12 times 1. Okay, that is for compounded monthly. Now we got to write it out for annually. We'll have P, and then it's going to be 1 plus, we don't know our rate, over 1, because it's 1 time a year, to the 1 times 1. So every single time the annual is going to break down into be 1 plus R. Okay, so we need to compare 1 plus R to whatever this piece is when I type it into my calculator. So parentheses 1 plus 0.035 divided by 12, end your parenthesis to the 12 times 1 or 12. When I do that, this part is 1.03, let's go 4 decimals, 556, so 56. And then those things are equal. And if I solve for R, I would subtract 1. So R is equal to 0.0356, which is 3.56%. So if you're compounded monthly, you are earning 3.5% each month. Okay, and then if you were to look at it, your overall investment for the entire year, you'd make a little bit more, 3.56%. Okay. All right, that is the end of the notes for lesson 4.4, day 3. Your homework is 1 through 53, and it's every other odd. So start at 1, skip 3, then do 5, then skip 7, 9, and continue on. And then also 67 through 72 all. Okay, so that is your homework. If you have any questions, feel free to message me. Otherwise, I'll see you later. Have a good day.